Hello guys, welcome to my channel. My name is Anirban Dash, and today we will discuss about the wave motion, and we will introduce you guys to wave motion, which is a chapter in class 11 physics. So let's start. I have bring to you all guys in a new format. That is, I have brought to you guys a kind of PDF form. So I will be giving you knowledge through these things today. So let's start. So here you can see that there is a kind of pond. So there is a kind of pond. Okay. So if you throw a stone like this here, then you in our youth ages when we are very small, means then we used to throw stones to the ponds, and then we can see that there is a kind of wave that is passing, that is this is kind of vibration like this. Okay. So when we throw the stone here, then a vibration that passes like this, from like a circular way, like this. First it starts like this, and then this, then it's trying to it used to spread. Okay. So here the same thing is happening that we all have seen from our child ages, that when we throw something in the pond, then it used to the in it pushes the wave, it pushes the water in like this. Okay, so this is nothing but the vibration that is happening on the water. Okay, so if you throw a stone in the in this way, then it happens, okay, like this. And then the vibration used to spread more and more like this. When this is like the length is this, but from here the length is more bigger, and here it is small, and it is going bigger and bigger and bigger. Okay. And after some time it will again back to this position. So this is continuously happening all the time when you just throw a stone in the pond. Other than that, the the pond is calm. Okay. So let's move on to this is the wave. This way you can visualize how the wave motion will work. We will deeply enter into the main topics which are involved in this wave motion. So let's continue. Okay. So what is a wave? So what is a wave? We will discuss it here, that what is a wave. So wave is a vibratory disturbance through a material medium, which a material medium or a space. Okay. So like this here, I told you that this is nothing but the vibration of the water particles. Means something like this is the water. Okay. So if the wave passes like this, then these particles used to get like this. Means it vibrates when someone's phone vibrate. Okay. Then the phone gets shaky, or the phone gets from here. If the phone is here, then the phone used to travel from like this, then from here to there the phone travels sometimes. Not that very much big, but not that very much, means slides the way, but some distance it travels sometime when you are keeping it the mobile into the hard surface. Okay. Then it happens. So like this, when we disturb the particles of water, then the vibration happens. So for that reason the waves these waves are created. Okay. So wave is a vibratory disturbance through a material. That material can be in a medium. That material can be in a medium, or that can be in a space. Okay. So wave is nothing but a vibratory disturbance. Whenever you see a wave, that must be that there is a vibration. Okay, without vibration, there will be not there will be any kind of uh, wave. Okay, for only when the wave comes into the action, then the vibration also has to be there. Okay, so wave is nothing but the transfer of energy. Okay, wave is nothing but the transfer of energy without transferring mass. They see, suppose this is a where. Okay, where. Okay, one second. Suppose one second. Suppose this is a where. Okay, so we all have done this, that uh, if we just touch this with our hand. Okay, then if we just shake the wire, then it used to go like this. The first wave, the first thing that happens, that if we will just pull it up and then put it down, then the first that happens, that is this, that it goes up. The first portion of the wire goes up, and then from here, then it travels the this vibration. This is a kind of vibration. Okay, there are particles, in the wire. Or if you will just see that there are number of divisions. If you will just create that, then you can see that each portion is getting up, and then it is just traveling. Then it happens, it goes to this, and then it goes to this, and this portion gets upward. So this happens. So this is the vibratory disturbance through a material. Okay, so this is a material, that is a wire, that is a material. Okay, so that the number of particles that are present in this material. Okay, so they are getting vibrated, or they are getting upwards, or they are getting they're following the SHM, or they are following they are something that is happening, that is oscillation. Okay, so I will do not spell that very much words to you, so that will be more difficult to understand. So what is this? That the particle is traveling like this, and then in the next step the particle is traveling like this. Okay, so at the end, that is happening, the wire is completely like this. The wire is going like this, and then it is going like this, and then after all it is coming like this, just like this. What happened here? That that uh, uh, first we throw a stone, then this wave happens, and this wave spreads a lot, then after that time, then it again back to this position. Okay, so what happening is here, that this is all the transfer of energy without transferring. So you can see that there is nothing changing in the mass of the material. Okay, there is only the vibration happening in the particle, or in the material. The particles which are present in that material, there only the transfer of energy or the vibration of the material is happening. Okay, I think it's clear to you. Okay, so let's move on to the next. So what are classical waves? Okay, so classical waves are nothing but that they don't require medium. Okay, suppose the here is an example given, that is light. Okay, so if we talk about the sound wave. Okay, sound wave require a medium. In the wave motion chapter, in wave motion chapter, there we all discuss about there we all discuss about the waves which require medium. Okay, so which require medium, here it is the a type of wave. Here it is a type of wave. And in the wave motion chapter, we all discuss about the wave which require medium. Okay, just like I have given this example, that is the sound wave. Okay, so the sound wave requires medium. Then we have discussed these examples. So in these examples here is a medium, and in this where there is a medium. Okay, so without medium this sound wave or like this they doesn't this doesn't perform. Okay, so the here no the wave which don't require any medium, that is light wave. Okay, so here the speed of the light that is given, that is noted as c, that is 3 into 10 to the power 8 meter per second. Okay, so this is the velocity of the light, and examples are given below, that is visible light, x-ray, infrared rays. Okay, so they these things doesn't require, there is no medium. Okay, they don't require any kind of medium. So okay, so this is called the classical wave. So let's move on to the next page, that is mechanical wave. So we will be we in the wave motion chapter, we all discuss about this mechanical waves. Okay, we all discuss about the mechanical waves, just like I have given you the in the previous slide, I have given you the example of the sound. So they require what I said, that they require medium. Okay, without medium they will not perform, or they will not get into work. Okay, so example, the sound, semic s waves. Okay, then transverse wave, example, water, seismic wave, light. Okay, so here it needs, I think the light here is given, this is wrong. Okay, 1 second, this is wrong. Okay, so let's go to the next one, that is transverse wave. Okay, so now what a transverse wave, the transverse wave here, the diagram that is given, that is wrong. Okay, so sorry for that, for showing you the wrong diagram here. I'm really very sorry. So I will draw the diagram for you guys. So let's come here. So see, suppose this is something, the attachment of something. Okay, so here the wave is passing. Okay, so the particles are moving upwards, and the direction of the wave is towards this side. Okay, so what can be the angle between them, the angle between them will be the 90 degree. Okay, so the energy, the transfer of energy is in this direction, the transfer of energy is in this direction. Okay, in the x-axis also you can say that, and the particles are traveling in the y-axis direction. So what is the angle between the x-axis and the y-axis? That is 90 degree. So that is same exactly happening here, that is the the particles which are vibrating upwards, and the wave that is going right side, or the wave that is following the x-axis. So the angle between them, that is comes the 90 degrees. So they are called the transverse wave. So here you can see the definition, that is waves move the medium at right angles to the direction in which the waves are traveling. So they are called this transverse wave. So the transverse wave, the main thing about the transverse wave is the pipe, not the pipe, sorry. Here the particles are traveling upwards, and the wave direction is towards right. Okay, so let's continue to the next type of wave, that is longitudinal wave. So here the actually that what happened, that the both the pictures got shipped, or both the diagram get shipped. Sorry for that. Okay, just let me just cut it. Okay, so what are longitudinal waves? The longitudinal waves have the vibration moving in the same direction that the waves are traveling. So 1 second, let me show you the picture here. So you can see this is the this is the picture of the transverse wave. Okay, this is transverse wave. Actually the diagram got shifted there and here. Okay, so this is the transverse wave. The direction of the vibration of the particle is towards up, and the direction of the energy transport wave the wave direction, okay, or wave propagating direction is different. Sorry, different means here it is per 90 degree, and the longitudinal wave looks like this, and the longitudinal wave look like this. Okay, so this is the example, this is, or say this is the diagram of the longitudinal wave. The vibration of the particles is like this. So if you can see this spring. Okay, so springs vibrate like this stretch, and this will show you as the most. Once again, yeah, this is one kind of this spring where it is one portion is like this, and one portion is like there are gap between those positions. Okay, so what is this? This is these positions are defined as the in the later we will discuss about this, the compression and the rarefactions. So these are nothing but the this is a serious example of longitudinal wave. Okay, this is a serious example of longitudinal wave. So let's move on to longitudinal waves. Okay, so they are nothing but the vibration in moving the same direction that wave is traveling in. The wave which in direction that the in which direction the wave is traveling, in that direction the vibration of the particles happens, like here, that is shown here. Okay, so let's move on to the next part, that is crest and the crown throw. Okay, so crest is a point on the wave where the displacement of the medium is maximum. So this is the point, this is the point here which we have drawn here. There the same thing happened, that is this position is crest, this position is crest, and this position, the maximum displacement of the particle happened here. Okay, the maximum displacement that happened here is this. So a crest is a point of wave where a crest is a point of wave where the displacement of the medium is maximum. So what is trough? A point on the wave where the displacement of the medium is minimum. Okay, the point on the wave where the displacement of the medium is minimum. Okay, so in this here, okay, here this is called the tau, that there is the minimum displacement that is happening, that is here. When there is no vibration, that is the minimum displacement, but I think so. Okay, so when there is the minimum displacement, that is the trough. Okay, that is the trough, and the crest is the maximum displacement of the medium at this maximum. Okay, so let's move on to the next slide. Okay, so what are compression and rarefraction? Okay, so compression is a region in a longitudinal waves where the particles are closest together. See, here it is discussed, that is, I have shown you guys that when the spring particles get close to each other, that point is called the compression, and when they gets away from each other, this position and this position, these are called the rarefaction. Okay, so and these positions are called the compression, because you can see obviously they are compressed when some particles are like this and some particles are like this. Which of the which you can say that they are compressed? They are compressed when in a bowl the gas is compressed in a small region, and when in this bowl the gas is taken up here, then which you can say that is it is compressed. They are means totally gathered around them so closely, and they here the particles are not gathered around them very closely. They are means having a distance. Okay, so that is that distance. When the particles are having a some distance between them, that is something that is called the rarefaction. Okay, rarefaction. Okay, and when the particles are compressed, or when the particles are having a minimal gap between them, or they are not having some gap between them, that position is called the compression. Okay, so let's move on to the next slide. So properties of wave, that is amplitude, that is frequency, that is speed, that is wavelength, these all are discussed in the slides. Just to show you the slides, what is amplitude? So amplitude is the maximum displacement. So maximum distance the particles. So particles of the medium carrying the wave move away from their rest positions. Okay. So suppose, okay, so this is the amplitude, means they are the this is the maximum distance of the particle. Suppose a particle is suppose suppose a particle is here, that this travels to here, then moves this from this position, this particle moved away. Okay, so it comes to here, then this is the maximum, this is the maximum point which the particle can come. From that point it can't. Okay, so when this position is reached, then it is called the amplitude. If you can also call in the downside, this is also the amplitude. Okay, so that is the maximum distance of the particle of a medium carrying the wave move away from the rest of the position. So amplitude is a wave. The maximum displacement of any particle producing the wave is called the amplitude. Okay, so it can be said also that this is the mean position, this is the mean position, and it is traveling like this and this and this. Okay, so amplitude of a transverse wave is maximum distance, is the maximum distance the medium moves up or down from the rest position. That I have said that when it gets down and when it gets up, then this is the maximum distance that happens. So amplitude of a longitudinal wave is a measure how the compressed or the rarefied medium becomes. Amplitude of a longitudinal wave is the measure of the how compressed and rarefied medium. Just like this case here, here it is at the 90 degrees or the right angles there, and in the longitudinal wave they are at 0 degrees. So like this example I have given you, this example. So in this here the same thing is happening, that when they are at the maximum distance, they that is called the amplitude here. Okay, so let's move on to the topic. Okay, so we have completed the amplitude. So here it is. See, this is the crest point, this is the trough point, and this is the maximum amplitude, and this is the wavelength, that is distance between a wave. Okay, so wavelength can be defined as the length of a complete wave, that is the distance between the two consecutive particles having the same phase at the instant is called. See, here is one particle, here is one particle, these particles are traveling. So this complete distance between them, is a wavelength. Okay, is a wavelength. Okay, so the length of the complete wave, so this is a complete wave, and then from here complete wave is uh, the complete wave is starting. So the distance between them, that is called the wavelength. Okay, so the amplitude is clear, the tau is clear. So let's move on to the next part, that is frequency. So frequency is nothing but wave of a wave. Frequency of a wave is the number of complete waves formed in unit time. Unit time is given, and number of complete wave means this is a complete wave, this is a then from here again a complete wave is starting. So here I say in unit time there are two complete waves, two complete waves sorry two complete waves are happening. Okay, in unit time there are two complete waves are happening. So we can say that the frequency is 2 hertz. That's the simple thing, is the frequency. Okay, so the number of complete waves that pass in a given point or a certain amount of time, the frequency is measured in hertz. Okay, so this is the unit of frequency, which is also denoted by Hz. Okay, so after this there are some formulas that is given here. The speed wavelength and the speed wavelength frequency of a wave are related to each other by mathematical formula. The speed that comes here, that is wavelength multiplied by frequency. Frequency can be here, frequency into wavelength is equals to speed. From there the frequency, the waves come down, so speed divided by wavelength. Okay, so wavelength can be also like this. From here the interchanging them, the speed divided by frequency. So our lecture of the introduction of wave motion ends here. We will continue the wave motion in our next classes. So till then, thanks for watching the video. If you like the video, then that will appreciate us, and comment down below what you want, what videos you want from us, and then subscribe for regular updates. So thank you very much for watching this lesson. Thank you.